Alright guys, I'm going to do a quick recording of May-June 2002, Cambridge paper 9702, and I suggest that everyone goes to 2002, 3 and 4, summer winter, because they have a wide variety and a very diverse set of questions, and if you can do them well, it covers most of your bases. I won't be editing it, so there's going to be a lot of noise in the background, and I apologize for that already, but we just need to get this done quickly. Alright, let's start. Which of the following pairs are both SI base units? I'll just go through the easy ones. I'll just go through them by just saying the answers, and I'll explain the ones a little more difficult or complicated. So yeah, so here are both SI base units is going to be B, ampere and Kelvin. The others are incorrect. If you go through them, you'll see why. All right, question 2. Diagram shows vectors x and y. Vector z, which is basically x minus y. So if you want to see that, you're going to see that x minus y, right? So minus y is basically going to be what? It's going to be, if this is y, then minus y is going to be in this direction. So you have x and then you have minus y. So you're basically having this plus this. So you have this. So your answer is going to be B. Z is upwards because y is going to be a minus value. So that's how you do that. All right, next question. Answer is B. All the others are impossible. This won't happen. That would be y minus x, and these are basically common mistakes that students do. They put one at the end of the other. But remember, this is a minus y, so you basically reverse this vector and then put it at the end of x. You get B as the answer. All right, for 3, this is a very common mistake students do. They end up thinking this is a waves question, and hence they try equating it and resolving it. But the easiest method to do this is, if you notice, it's at the beginning of the paper, which means what? It's a base units question. So they want to see which one of these equations is correct. So according to the concept of homogeneity, if the equation is correct, we will know that meters per second is the unit for base units for velocity. So on the right hand side, the units also has to be meters per second. So if you go through this really quickly, you're going to see g lambda, right? So g is going to be what? Meters per second square, and lambda is meters. So if you multiply the two, it's meters square per second square. Root that, you get meters per second. So your answer is actually A. Usually these questions, the answer is A or B, because they don't expect you to derive all of them and end up at D and then say that's the answer. They don't want you to waste too much time on it. So your answer is A. That's it. Question 4. Alright, so look at this equation. They drew a graph of root h versus t, where h is equal to half dt square. So very easily we can see that this is a y is equal to mx plus c format, but they don't have any c value, which means it's supposed to pass through the origin. It didn't. So this is one thing we're noticing, that it didn't pass through the origin. Another thing we're seeing is there's a little bit amount of scatter around the values. So basically the scatter represents random error, and the fact that it didn't go through the origin represents systematic error. Alright, now let's see the question. Which of the following is an explanation for the intercept on the t-axis? It's not supposed to have an intercept. So what does that mean? It's giving extra time, right? So air resistance has not been taken into account for large values of h. If this was the case, then you would have actually intercept at t, and the graph would curve, because at higher values of h, you would have more and more significant effect of t. That would take more time, right? So we're not seeing that happen. It's actually a straight line. So that cancels that possibility. Then what is the other options? There is a constant delay between starting the timer and releasing the ball. All right. This sounds like a systematic error, and this is most likely the correct answer. So because it explains why each and every value has an increased value of t, it's supposed to be on this side, but here it's moved off to the right. So basically that is a possible explanation. Let's see the others and see. There is an error in the timer that consistently makes it run fast. If that was the case, it will still pass through the origin, but it would be further out for each of the values. So it would be basically less slanted, right? So it's still passing through the origin. So yeah, that can't be the answer. And students should have plotted h against t square. Again, this isn't logical reasoning, because if you plotted h against t square, you're going to get the same behavior. So basically your answer is B. There you go. So answer for 4 is B. So 5 is a very simple question. P is equal to v squared by r. The uncertainty the uncertainty and the potential difference is 3%. Uncertainty resistance is 2%. So V squared by R. So V is going to have an uncertainty of 3%. So V squared is going to be 3% plus 3%. Remember the thing, when there's multiplication or division, you add the percentage uncertainty. So it's going to be V plus R. So that's 3 plus 3 plus 2. And that gives you an answer of 8%. So answer to 5 is C. All right, question 6. In question 6, graph relates to motion of a falling body. Which is a correct description of the graph? Y is distance and air resistance is negligible, blah 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 blah. If we go through all of the options, what you're going to see is this is basically a graph that you're pretty familiar with by now. I hope so. It's basically a terminal velocity graph, right? So what does that mean? That it's speed, y is speed, and air resistance is not negligible. So which one do we see as the answer? We're going to see y is distance, no. Y is speed, resistance is negligible, no, it's not negligible. So your answer is D. Y is speed and air resistance is not negligible. Alright, question 7. Which, so answer is D for 6. All right, number 7. Which graph blah 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 uniformly increasing speed? So that's uniformly increasing speed represents what? Uniform acceleration. So directly your answer is A, because the x-axis is time and the y-axis is acceleration. B is increasing acceleration. C is constant velocity, and D is at rest. The displacement isn't changing. So it's a common mistake students do. They choose D, but the answer is actually A. All right, then question 8. Stone is thrown upwards from a cliff. After reaching maximum height, it falls past cliff on the top of the sea. All right, into the sea. Sorry. So if we were to draw this to make it simpler, say this is the cliff and this is the sea. All right. So someone throws a stone and it goes like this, right? So the distance it's moving up is distance s, and from the highest point into the sea, this is distance r. So they want the distance of the height of the cliff. So how do you find that? That's going to be r minus s. Really simple. All right. So if that gives you, if we look at the options here for the question, you're going to see that it's going to be r minus s, and your answer is D. There you go. All right. Question 9. Head-on elastic collision. That's all I'm going to read. V, it's all given here. I'm just going really fast. I suggest you don't do that in the actual paper, obviously. Which statement is correct? Well, if it's a head-on elastic collision, that means what? Kinetic energy is conserved. Speed of approach is going to be equal to speed of separation. All right, so let's see. What's the total kinetic energy when they're before the collision? It's going to be half mv squared plus half mv squared, which is basically mv squared. All right. A. Spheres stick together on impact. Impossible. That's a totally inelastic collision. B. Total kinetic energy after the impact is half mv squared. That is the correct answer. Total kinetic energy before impact is 0. Wrong. Total momentum is 0. But the kinetic energy is a scalar quantity, so you add them up regardless of direction. And total momentum before impact is 2 mv. Again, this is wrong. It's going to be 0 because this is going to be mv and this is going to be minus mv. Momentum is vector. Energy is scalar. That's why C and D are actually opposite answers. But however, here the answer is going to be B, because momentum after collision has to be the momentum before collision. Sorry, kinetic energy before collision is equal to kinetic energy after collision, which is mv squared. All right, now let's go to question 10. Rough horizontal surface, blah blah blah. Easy question. I expect you guys to be able to do it. F is equal to ma. This is what you do. So the mass is going to be 0.6. A is 4 meters per second square. So how much force is there? 0.6 times 4, which is 2.4 newtons. But you're applying a force of 12 newtons. So how much force is actually being used to accelerate it? Only 2.4 of the 12. So what about the rest of it? It's being used to work against friction. So your answer is B, 9.6 newtons. All right, there you go. Initially at rest, explodes m1, m2. So you have two masses which were at velocity 0 and momentum 0. Speeds v1 and v2 respectively. So m1 v1 and m2 v2. So if they explode and they have to conserve momentum, so that means what? The momentum of one piece has to be equal and opposite to the momentum of the other piece, because initially they were at rest. m1 v1 plus m2 v2 is equal to 0. So that gives you m1 v1 is equal to minus m2 v2. If we ignore the minus for now, we get an equation m1 v1 is equal to m2 v2. So if you equate that, you're going to get v1 by v2 is equal to m2 by m1. So your answer for 11 will be B. Alright, submarine descends vertically at constant velocity. Three forces acting on the submarine are viscous drag, upthrust, and weight. So if we were to draw, say, like, submarine. Alright, so we have a weight which is acting downwards, and we have two forces acting upwards, which are what? Viscous drag, and we have upthrust. Remember, viscous drag only acts opposite to the direction of motion. So here, as they're saying, it's constant velocity, which means what? The total upward viscous drag plus upthrust is equal to weight. So yeah, here the largest force is obviously going to be weight, and by that, if we now go through the options, we're going to see that weight is less than drag, no. Weight is equal to drag, no. Weight is less than upthrust, no. Weight is more than upthrust. Answer is 12D. Right, question 13. So this is a basic vectors question where you have a 2 Newton force at a 50-degree angle, blah blah blah. So if you take a sine component of this and you take a sine component of this, you always remember you have to for moments you always have to calculate perpendicular distance, right? So here they're saying that the rule has a length of 0.3 meters. So if that is the case, one way of doing this is you take the force component which is perpendicular to this and this is going to be sine components of each one, and you take the distance between the two as 0.3 meters, and then you find the torque of the couple. And you should know the formula for torque of a couple is the force multiplied by the perpendicular distance between the two forces, right? So your answer for 13, if you do the calculation correctly, will be C, 0.46 Newton meters. Alright, next, cylindrical block, wood, cross-sectional area A, blah 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 blah. Basically, upthrust acting on the block. It's totally immersed in water. So basically we know what upthrust is due to difference in pressure, right? Pressure increases with depth. So if you take a block and if this is water and if you go deeper, there's a certain pressure acting on the top of it and there's a certain pressure acting on the bottom of it. This is what they're saying, pressure top and the pressure bottom. So PT and PB. So we know force is equal to pressure into area, right? So if that is the case here, uh, here what we're going to do is pressure top and pressure bottom. So basically the difference between the pressure is what's causing upthrust. So it's going to be PB minus PT, right? And you have to multiply this with the area, cross-section area on which it's acting, so that you can find the force acting on it. And the difference between these two forces is going to be the upthrust. So that gives you PB minus PT is the difference in the pressure multiplied with the cross-sectional area A. So your answer is C. All right? I hope you get that. If you don't, you can always just send me a message and I'll explain it again to you. Alright, next question, 15. So you have a 3 Newton force in this direction or 4 Newton force in this direction. If you do Pythagoras of these, you're going to get 3 square, 4 square, 25. Root that, you're going to get a 5 Newton force in this direction. So if you have a 5 Newton force acting in this direction and you have a 4 Newton force acting in the opposite direction, then obviously you're going to have a resultant of a 1 Newton force acting, right? And which way will it act? In the direction of the 5 Newton force. So your answer is going to be D. So that's how you do this. Alright, next question. Alright. Power is transferred through a machine, blah blah blah. Really stupid question. Efficiency of the machine is going to be D. Alright. Power output by total input. Alright. I won't go into details of that. 17. Alright. You need to know the equation. Work done is equal to force. Work done is pressure into del V. Pressure into change in volume. So if you take that into consideration, what's the change in volume here? It's going to be V1 minus V2. So it's V1 minus V2 and you multiply it with the pressure. So answer is C. 17C. There you go. Really easy actually. Alright, let's move to 18. Alright, a lot of students face this problem. They come across this and they get stuck at this. It's a pretty common repeat also. So pay attention to this one. Trolley runs from P to Q along a track. Q is potential energy of 50 kilojoules less than P. Which means what? If something is at P, this trolley for example, it's at P, its potential energy is greater than the potential energy at Q by how much? By 50 kilojoules. Whoops. So that basically means what? That if this trolley was to travel from here to here, then it would increase its kinetic energy. By how much? It will increase by 50 kilojoules. Alright, and next piece of information they give is that the trolley already has 5 kilojoules. So how much energy do you have in total? You have 50 plus 5, 55, right? However, all of it will not be turned into kinetic energy because you're going to lose 10 kilojoules as the trolley is going to be moving from P to Q. So 55 minus 10 kilojoules, you're left with 45 kilojoules. So that's what the question is. What is the kinetic energy of the trolley at Q? It's going to be 50 plus the 5, and then as you travel, you lose 10. So you get 45 kilojoules of energy. Really simple. Alright, next question. To travel at a constant speed, a car engine provides 24 kilowatts of useful power. The driving force on the car is 600 kilonewtons. Right, at what speed does it travel? So basically power is equal to force into velocity. If you do that calculation for question 19, your answer should be D. Alright, easy. For a given liquid atmospheric pressure, which process can occur at any temperature? This question was previously in the syllabus. It's no longer in the syllabus. They've changed it to the A2 syllabus, but however the answer is going to be for question 20, it's evaporation, right? It's a really simple question, but I'm not going to go into it. So 21. Alright, so this question people face in a lot of problems with. Mass of liquid density rho is thoroughly mixed with equal mass of another liquid density 2 rho. No change in the volume occurs. So here, if you notice this, you're going to see that if you have a liquid of, notice this, thoroughly mixed with an equal mass of another liquid. So if they have an equal mass, but the density is 2 rho, the volume is going to be less. So the mistake that students do is they take the volume of this as V and the volume of this as V also. If you were to take equal volumes, you're going to have twice the mass. But for equal mass, you'd have to take half V. So total volume you're going to have here is 1.5 V. And the total mass you're going to have is going to be 2m. So density equal to mass by volume. So 2m by 1.5 V, if you do the calculation, you're going to get as 3 by 2 rho. That's going to be your average density. Wasn't it? You'll have to do the calculation here. I think it's going to be 4 by 3 rho. Answer is A. Yeah. So that's what you'll have to do for the calculations. Anyway, next question. But that's the concept behind it. Which of the following correctly defines stress strain in a Young modulus? This is pathetic. I won't explain it. Answer is C. Stretched wire 8 millimeters load 60 newtons is applied. What is the extension of the wire? Same material having 4 times the cross-sectional area and twice the original length. Alright, so whenever you come across these sort of questions, what I would suggest is you look at the question and you try to approach it from a unitary method perspective. So 8 millimeters, 60 newtons, right? So here what you do is 4 times the cross-sectional area. So if you were to apply a 60 Newton force on something with 4 times the cross-sectional area, it would extend by a factor of 4 times less. So if it's 8 millimeters, it would go down to 2 millimeters. So there you go. Then you read the next part of the question, and twice the original length. So if you increase the length, what do we know? That the extension increases also. So if it's twice of that, so we calculated how much here? 2, right? 4 times the original cross-sectional area. So it's going to be 2, but then again twice the area, so it's going to be twice that, right? So like 2 plus 2. So your extension is going to be how much? A total of 4 millimeters. So yeah, you can very easily answer these with very little calculation. Tension spring, length, blah blah blah, length. So basically what they do is they have a spring, they extend it from L0 to L1, and then they decrease it to L2. And the tension is then reduced to T2, and length of L2. So basically they're asking which area on the graph represents the work done by the spring during the reduction in length. Always go back to the easy equations and stuff we have, and the equation here is work done is force into distance. So the distance covered is basically L1 and L2, and the force is basically the change between T1 and T2. So if you do this, you're going to get this as the area, and based on that, for 24, your answer should be NMQP, which is basically this area. Alright, let's move forward. Which of the following summarizes the change in wave characteristics going from infrared from ultraviolet? Retarded question. I'm not going to explain this. Its answer is C. Alright, 26. Diagram shows a cathode ray oscilloscope sound wave. Time base is calibrated at 2 milliseconds per centimeter. Alright. So here, what do they want? Before we get into the question, let's just see this. 2 milliseconds per centimeter. So basically each wave here, if you count the boxes horizontally, each cycle is 4 boxes, right? So you can count it twice if you want to be sure. So 2 cycles is a total of 8 boxes. So each cycle is 4 boxes. So 4 boxes means the time period is how much? 8 milliseconds, right? What is the frequency of the sound wave? We've already done the equation. We know it. The answer is what? 1 by 8 times 10 to the power minus 3. So if you do that calculation properly, your answer for question 26 should be 125 Hertz. F is equal to 1 by T. That's how we solved it. Alright, 27. Again, this is a memorization of an equation. Intensity proportional to amplitude square. So your answer is going to be B. Done. Alright, 28. Yeah, this one a lot of people face problems with. Now let's read this question in a little bit of detail so we know what we're talking about. Demonstrate two source interference. So this is basically double slits. You're going to have maximas and minimas here, right? And these are the two slits. When are you going to have maximas? When there's constructive interference. When are you going to have minimas? When there's destructive interference. So the detector is moved from O in the direction of the arrow. The signal detected decreases until it reaches point X and then starts to increase again. So which means what? X is actually a minima. So O is a maxima and then X is a minima and then it starts increasing again. So when would you get the first minima? When the path difference is how much? Half lambda. So path difference between what? S2 to X and S1 to X. If you subtract the two, you're going to have a path difference of half lambda. It's as simple as that. That's exactly what they want in this question. So now if we read through the next part, which equation correctly determines the position of X? Well, if you don't look at it from this perspective, it gets really complicated. You start trying to do trigonometry and all of that, blah, 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 which you don't actually have to do. So basically, the distance between S1 to X and S2 to X is going to be half lambda, and the equation which comes closest to this is C. S2X minus S1X is equal to half lambda. There you go. Question 29. Two progressive waves, 300 kilohertz, are superimposed to produce a stationary wave with adjacent nodes which are 1.5 meters apart. What is the speed of the progressive waves? Again, very simple. You basically have the frequency of the progressive waves and the wavelength. If the distance between two nodes is 1.5 meters, what do we know? If we just I'll try to draw a standing wave really quickly. Whoops. So anyway, so this is a node, this is a node, this is a node, supposed to be node, and this is a node, and the points between are antinodes. So distance between two adjacent nodes is basically half lambda, because you need to multiply that by 2 to get the total lambda, and that's true for also the distance between two antinodes. As that is the case here, you're going to see that half lambda's distance is 1.5 meters. So that basically means what? The wavelength is actually 3 meters. So C is equal to F lambda, C being the value that you need to calculate. F is 300 and lambda is 3 meters, so your answer is D, 900 meters per second. That is your answer for 29. Alright, question 30. Graph show variation current I for 3 circuit elements. If you know these, you know these. If you don't, you don't. This is a diode, semiconducting diode, reaches a certain value in forward bias or positive value, and then suddenly the resistance drops, and in the reverse direction it just keeps going straight, or it's supposed to. This is an ohmic conductor, right? So an ohmic conductor is basically a wire or whatever at constant temperature, and this is a filament lamp. You've already seen these sort of graphs, and the graph curves because as the temperature increases, the resistance increases, so the increase in current is less. 3 circuit elements: metal wire, constant temperature, semiconducting diode, and filament lamp. So we already know what that this is a diode, this is a constant temperature conductor, and this is a filament lamp. So for your answer to 30, you should have B. Metal wire is Y, semiconductor diode X, and filament lamp is Z. Alright, moving forward. Again, a retarded question. Which expressions give EMF of the battery and the current in the resistor? Alright, so for this, your answer is going to be C. EMF is E by Q and current is Q by T. Again, these are equations. 32. Filament 240 volt 100 watt electric lamp heats up at room temperature to its operating temperature. Heats up, the resistance increases by a factor of 16. What is the resistance of the lamp at room temperature? So you have to do a calculation here and find the resistance first, right? So P is equal to, you could say, I square R, right? So you do the calculation. I'm not going to go into it because it's just too simple. And whatever value you get for the resistance, you divide it by 16 and you're going to get the answer. And so at room temperature, because it increases by a factor of 16, when it's operating at these values, it's 16 times more than the room temperature. So if you do the calculations, you should get, for answer 32, A, 36 ohms. So remember this is at room temperature. You multiply it with 16, you're going to get this resistance when it's operating. Wires connected I1, I2, I3 and I4 related by the equation I1 plus I2 is equal to I3 plus I4. Remember, this is from Kirchhoff's first law. Current entering a point is equal to current leaving a point, a conservation of charge law. So we basically have to have a junction where I1, I2 are either together leaving or together entering, and same for I3, I4. If I1, I2 is entering, I3, I4 should be leaving. Current entering the point must be equal to current leaving the point, or similarly. So if we look at the options, it's simple. We're just going to see if I1 and I2 enters, I1 and I2 don't enter here, gone. So let's try this one. I1 exits, all right, I2 exits, fine, that's nice, but also I3 exits, so gone. It can't be this. So C, let's look at C. I1 enters, I2 enters, good. I3 leaves, I4 leaves, perfect. So our answer is C, and if we want to see, we can also look why D is not the answer. They're all entering together. So your answer is going to be C. All right, question 34. All right, this question, if you look at this, they have normal brightness. So when the four lamps are connected and shown in diagram 2, which statement is correct? If you pay attention to this, you're going to realize that both setups are exactly the same. Say this is a 6 volt EMF. This is also a 6 volt EMF. So the PD across here is going to be how much? It's going to be 3 volts, right? And the PD across this is also going to be 3 volts because they're parallel to these, but they're series to the battery. So basically 3 volts, whatever voltage you're going to get 3 volts across these also. So you get 3 volts across each one of these. If you look at this, you're going to see you're going to get 3 volts across this, you're going to get 3 volts across this. And you can actually redraw this diagram to look like this diagram. So basically means that these two circuits are almost the same. The only difference is the lamps labeled P and Q are not in series. Here the lamps labeled P and R are in series and Q and S are in series. But as they're identical, it doesn't really matter. You're going to end up getting the same circuit again. So your answer for this is that they're all going to light up to the same brightness, which is C. The lamps have normal brightness. All right, we can move on forward. Okay. This is a question where students actually do face a lot of problems. Again, let's look at this really quickly. A potential divider is used to give outputs of 2, 3, and 4, 5 volts as shown. So if you have an EMF of 5 volts here, and this has an output of 3 volts, the drop across this is how much? 5 minus 3, right? So you have a drop of 2 volts here. 3 and 2, so what's the drop between these two? It's going to be 1 volt. And from 2 to 0, what's the drop here? It's going to be again 2 volts. As these are in series, R1, R2, and R3 are in series, we can use V is equal to IR. And they're in series, so the value of I is the same. So the voltage across each one is actually proportional to the resistance of each one. So this has a voltage drop of twice of this, and then again this is the same as this, which is again twice of that. So you could say that the voltage for this, if they're proportional, you could say the resistance of this is 2R, then the resistance of this is also 2R because it's 2 volts, and the resistance of this is 1R. So we just see which of the options actually matches up with the same ratio. If you look at the options, you're going to see that according to what we're looking for, your answer is going to be C, 4, 2, 4, right? 2, 1, 2. So that's how you do these questions, and then you solve this, and that's how you get the answer. All right, question 36. Which parts of the possible movement of an electron in electric field? So always remember, field lines represent the direction of current flow, force acting on a positive charge, which means what? Field lines always travel from higher potential to lower potential. This is going to be the positive plate and this is going to be the negative plate. So the electron will obviously move upwards. So if it moves upwards, our possible answers are B or C. Right. So now, even though it might seem so, B is actually a straight line. So that's why we can very easily ignore B. Why? If a force is acting on it, it will not travel along a straight line, it will actually curve. So you can't have this happening, and even if it does travel along a straight line, it will do it after it exits the field. Within the field, it must curve. And even if it's moving really fast, there should be some slight curve, so which is not very obvious here. So our easiest answer is A. So for 36, our answer is A, and we obviously know why it's not D or C. It's not D because obviously electrons will not be attracted towards the negative plate, they'll be repelled by the negative plate. And C, like B, it's a straight line. So it just curves once here, and hence we can ignore it also. Moving on to the next question. All right, you need to pay attention to this sort of question. They're talking about two parallel conducting plates. Basically, it's the same setup as this. Connected a battery across one plate, positive terminal, another plate to the negative. Plate separation is gradually increased. The plates remain connected to the battery. This is the most important part. Plate separation, plate separation is gradually increased. This is what you need to pay attention to. If the separation is increased, your answer will always be A, because field strength E is equal to V by D. V is the potential difference and D is the distance between the plates. So if that increases, field strength will decrease. Answer is A. A similar way that they're going to ask this question is the distance between the plates is kept the same, but a charged particle is gradually, distance from a charged particle from one of the plates is gradually increases, like moving a positive charge from one of the plates towards the other. So you really need to read the question carefully. So if you're going to see that, you're going to see your answer is going to be D, because the field strength doesn't change because the distance between the plates don't change. It's a uniform field, it's constant throughout, but in this case, as the plate separation is gradually increased, hence the field strength will decrease according to the equation E is equal to V by D, and your answer is A. Alright, that's question 37. So question 38, radioactive emissions correspond to the descriptions of table headings, blah 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 blah. I'm not going to even read it. Answer is C. Don't do that in the exams. Nucleus isotopes nickel represented 6028 nickel. Which line in table correctly describes the neutral atom of the isotope? So if you do the calculations properly, you should have equal number of protons and neutrons, right? Sorry, protons and electrons, because it has to be a neutral atom. Whenever there's an uneven number of protons and electrons, it's going to be non-neutral, obviously, and it's going to be an ion. So if there's more electrons, it's negative. If there's more protons, it's positive. In this case, we look at whichever value is the same. And for here, the answer is actually A, 28 protons and 28 electrons. So there you go. All right, last question. Nucleus of borium decays to mendelevium and a sequence of 3 alpha particle emissions. So if borium decays to dubnium, what happens is it loses 2. So yeah, let's do this actually by writing it. It's going to make it easier. So we end up with mendelevium, right? So then you want to know what's the year of borium. So basically this is 4,2, right? So if that's the case, you add these up to mendelevium and you're going to get lawrencium. So if you add them up, what do you get? You get 259 and you get 103. All right, sorry about the handwriting, but whatever. So, and then you add another alpha, which is another 4,2, to lawrencium to get dubnium. So if you add that, what do you get? You get 263 and a 2 down at the bottom, the atomic number, which is 105. And you add another alpha to that to give you borium. So that's going to be 267 and 107. All right, now the question is, how many neutrons are there going to be in this? So if you do the calculation properly, you're going to get what? Neutrons is basically atomic mass and number the difference between the two, because there's number of protons, there's a number of protons and neutrons. So 267 minus 107 is going to give you 160, and your answer is C. Yeah, there you go. That's how you do question 40. It's very easy. I hope to do the next questions very soon. And if you still have any problems, you can always just let me know. I'll try my best to get back with the answers and further explanations. I hope we're done.